Okay, today we're going to be learning section 4.2. We just talked about the unit circle and we derived that earlier in the week, and we learned that cosine is x and sine is y. We also learned that we have the square root of 3/2 being the cosine of 30 degrees and 1/2 being the sine of it, and so forth. So we're going to go over and we're going to talk about more various trig functions. So the 6 trig functions that we're going to be talking about. Trigonometry is the unit circle constructed by the use of right triangles to find 6 trig functions. Sine, which is understood to be sin, cosine, which is the cos, cos, tangent, which is tan, cosecant, I remember that because it ends in a C, the S is on the inside, secant, it had the S on the first one, cotangent is cot. Okay, those are the 6 trig functions that we are going to be memorizing. Out of those 6 trig functions, which your brain needs to understand, is sine, this is the y value. Always and forever the y value. Okay? The sine of theta, alpha, beta, gamma, phi, those are all examples of trig letters. Okay? All those trig letters represent is this unknown angle. Cosine is going to be the x value, and again, cosine of theta, theta is any angle. What your brain needs to get is this page right here. Cosine of t, t can be an angle as well, is x, sine is y. Tangent is sine over cosine, which means it's the y value over the x value. If you know those 3, then the reciprocals are the next 3. The reciprocal of tangent is 1 over cosine, so therefore it's 1 over x. The reciprocal of cosecant is going to be the sine function, so that's 1 over sine, which is 1 over y. Again, your x and your y can't be 0 because can you ever divide by 0? No, that's what we call undefined. The cotangent is going to be the inverse of tangent, so that's going to be 1 over tan. So that's going to be, instead of y over x for tangent, it's going to be x over y. So these are the 6 trig functions you need to memorize, and we are going to apply them using SOHCAHTOA. We used SOHCAHTOA whenever we derived our lovely little unit circle. Same exact concept. Sine is opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And then lastly, tangent is going to be opposite over adjacent. And that is where you learned that back in geometry. Our unit circle. We derived this. This is the one that you've been using. This is what I need your brain to understand. Hands of the clock. 0, 1, 2, 3. You're going to hear me say that repeatedly. 0, 1, 2, 3. I am always talking about the cosine functions whenever I say 0, 1, 2, 3, because that's 1 o'clock, 2 o'clock, 3 o'clock, 60 degrees, 45, 3 o'clock is going to be the hands of the clock that creates that angle. Okay? Then you will also see that this is 2, 3, 4, 6. That's helpful for you. Okay? Another key that's going to be helpful for you is the denominators of 6 all hover around the x-axis. All the denominators of 3 are going to hover around the y-axis. Super important. Okay? And then the last one that you need to see is the pi over 2's are going to be at the bottom. Again, 1, 2, 3, 3, 2, 1. So it's 1, 2, 3, 3, 2, 1. All on your x-axis, all on your x values. 1, 2, 3, 3, 2, 1. Okay? Always talking about your x cosine values. 1, 2, 3, 3, 2, 1. Okay? Now, next. Odd functions versus even functions. Now, back in the day, we talked about odd and even functions algebraically. And the sine of a negative angle is equal to negative sine of that angle. Okay? The sine of negative an angle is equal to negative times the sine of angle. That is with every one of these. These are all your odd functions. That will always be true. They're on your formula sheet that I gave you at the very beginning of the packet. Okay? Cosine of a negative angle is just equal to the cosine of that positive angle. Okay, so these are things that you're going to use for substitution, and we'll come back to them as we do them. Tonight's homework is 4.2, bookwork 1, page 264, 2 through 52 even. Now, obviously I haven't been recording for very long, so we're going to go right into your homework. and start that. So 4-2, bookwork 1, page 264, 2 through 52 even. The directions say, for problems 1, it literally says determine the exact values of the 6 trigonometric functions of the angle. So if I am doing that, I give you the ordered pair -8/17 and 15/17. And it gives you an actual circle where you can see it. Here's what your brain needs to understand. I'm giving you an ordered pair. So that means that ordered pair has an x and a y value. Yes? So that means x is equal to my cosine value of my theta angle, which means that's -8/17. The other thing that is given to you is y, which is 15/17, and that's going to be equal to the sine value of my theta. Okay? So remember, if I give you cosine and sine, then you know the reciprocal of that. The reciprocal of cosine is going to be secant. The reciprocal of that is going to be, take the reciprocal, 17/8. The reciprocal of sine is going to be cosecant, and if that is 15/17, that's going to be 17/15. Okay? Now, if I know sine and cosine, then tangent is simply going to be the sine value divided by the cosine value. So I'm going to have -8/17 divided by, and I lied, that's the cosine. So what that means is I'm going to have 17/15 divided by my cosine -8/17. Now notice how I wrote that horizontally. That means if I multiply by the reciprocal of the second fraction, I'm going to get this. When you divide by it, you get this right here. Now, give me 1 second. Okay, I wrote the wrong one here. Sorry, guys. Hope you guys caught me on that. I literally transposed it in my head. It's 15/17 and then 15/17 here. The 17s cancel out, so the tangent is going to be 15/8. That is your tangent of theta. So if I know my tangent, then I automatically know my cotangent because that's the reciprocal to give you -8/15. Okay? So we have found the 4 remaining trig functions, and those are those answers right there. Okay, next, it says find the point xy on the unit circle that corresponds to the real number t. Well, I need your brain to figure out where is pi/4. Pi/4 is going to be in quadrant 1, and it's the 45-degree angle. The 45-degree angle that corresponds with that in quadrant 1 is always positive, and that ordered pair is the square root of 2/2, square root of 2/2. So it says to find the point. That is the point because I'm in quadrant 1, and anything with a denominator 4 corresponds to the ordered pair square root of 2/2, square root of 2/2. If you're not certain, I'm going to clear this page. The angle that it's talking about is right here, and there's the ordered pair. Okay? Next, 7pi/6. Well, 7pi/6 has a denominator of 6. Immediately, your brain should be saying, okay, if I'm in my first quadrant, denominator of 6 is right here, so that's the square root of 3/2, 1/2. But that is the ordered pair that it corresponds with, but I have to now determine what quadrant I'm in. Well, here's 6pi/6. How do I know that? Because it's denominator 6. So that means 7pi/6 is in my third quadrant, which means they both are negative. Do we understand that? Why? Because denominator of 6, I have 6 equal pieces on the top of the pizza, 6 equal pieces on the bottom, and I want a whole 7 of them, which means I have to be in quad 3. Okay? If I want to check my unit circle right here, you can see here's 7pi/6. It is 210 degrees, and they are both negative. Okay? That is how you utilize your unit circle. Notice I didn't pull out my unit circle and then copy from it. I thought it through so that I knew what I was doing. Okay? Next, evaluate, if possible, the sine, cosine, and tangent. I only have to do 3 of the 6. Okay. Well, pi/3, 1, 2, 3, hands of the clock. That's 1/2 square root of 3 over 2. That's the ordered pair that deals with pi over 3. That's in quadrant 1. So I know that my cosine of pi over 3 is going to be my x-coordinate, which is 1/2. My sine of pi over 3 is the y-coordinate, which is the square root of 3 over 2, which now means my tangent is going to be my sine value divided by my cosine value. So when you divide by a fraction, you are multiplying by its reciprocal. The 2's cancel out, and I have just the square root of 3. So that is how you are going to do the sine, the cosine, and the tangent. Remembering you are doing this off of your brain from the unit circle. Okay? Number 18, negative 4 pi over 3. Okay, well, here's what my brain should know. It's a denominator of 3. Denominator of 3 means it corresponds to this ordered pair of 1/2 square root of 3 over 2. But I need to determine what quadrant I'm in. So the quadrant I'm in is going to be, here's going to be 0, here's negative 3 pi over 3. I need 4 of the 6 total pieces in the pie. So that means that this is negative 4 pi over 3. So that means I'm in quadrant 2. So when I'm in quadrant 2, that means my x value is negative and my y value is positive. So I have negative 1/2 positive square root of 3 over 2. So I still need to go ahead and according to the directions, I need to evaluate the sine, cosine, and the tangent. So that means that the cosine of negative 4 pi over 3 is my x value, which is negative 1/2. My sine of negative 4 pi over 3 is going to be positive square root of 3 over 2. That leaves the tangent of negative 4 pi over 3 to be my sine value divided by my cosine value, which means I am flipping the second fraction, putting multiplication. The 2's cancel out to give you negative square root of 3. So there is the 3 values for the negative 4 pi over 3. Okay? Evaluate, if possible, the 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Okay? 5 pi over 6. Well, 5 pi over 6 corresponds with the square root of 3 over 2, 1/2. What quadrant am I in? Well, the quadrant that I'm in is going to be 0, and this is 6 pi over 6. I want 5 of them. So here's 5 pi over 6, so I'm in quadrant 2. So that's a negative and a positive. Do we see how I did that? I want 6 pi over 6 here. I only need 5 of them, so that puts me slightly above it in quadrant 2. And that's going to give me a negative square root of 3 over 2, positive 1/2. Okay? How did I know it was the square root of 3 over 2, 1/2? Because that's the denominator of 6, and that's the ordered pair that corresponds to a denominator of 6. So I need to do all 6 trig functions. So I'm going to go ahead and write sine of 5 pi over 6, cosine of 5 pi over 6, and then tangent of 5 pi over 6. Now, does everybody understand that I wrote sine first instead of cosine? I did that strategically because I know that tangent is sine divided by cosine, so I put that first. So I have 1/2, I have negative square root of 3 over 2, and then this one, watch. The 2's cancel out, and I'm left with negative 1 over the square root of 3. Okay? That's a nice little trick for you, okay? Now, I cannot leave it as this. I have to rationalize that. So when I rationalize that, I'm going to get negative square roots of 3 over 3. Okay? Now, I need the reciprocal functions of this. The opposite of sine is going to be cosecant of 5 pi over 6 is simply going to be the reciprocal of that. So that's going to be 2 over 1, which is 2. Then I need the reciprocal of cosine is going to be secant. So that's going to be 2 over negative square roots of 3. Rationalize. So that's 2 square roots of 3 negative 2 square roots of 3 over 3. And then the cotangent of 5 pi over 6. I am going to grab this right here in red, and I'm going to take the inverse of that, which is simply going to be negative square roots of 3, and that's going to give me less to rationalize. Okay? So that's number 24. Next, 29. Evaluate the trigonometric function using its period as an aid. Its period means how many units does it take to get around the unit circle, and that is 2 pi. So what you're actually going to be utilizing here is 2 pi, meaning how many revolutions around the unit circle, okay? So the sine of 5 pi. So if I take 5 pi and I subtract off 2 pi, because it's bigger than 2 pi, that gives me 3 pi. That's still bigger than 2 pi. Do it again. That gives me pi. What this means is this 5 pi is the same thing as 3 pi, which is the same thing as pi. They land at the exact same spot on the unit circle every revolution, okay? Which means the sine of 5 pi is the same thing as the sine of pi. What ordered pair corresponds to the value pi? That is going to be negative 1, comma 0. It says to evaluate that. I want the sine. So if I want the sine, that means I want the y coordinate in that point. That means it is going to be 0. Okay? $34? 34 is the exact same thing. Negative 19 pi over 6, I'm going to add 2 pi. What is 2 pi actually? That's 6 times 2, which is going to be 12 pi over 6. Negative 19 plus 12 pi is going to be negative 7 pi over 6. If I add another 12 pi over 6 to that, that's going to give me a 5 pi over 6. What this means is negative 19 pi over 6, negative 7 pi over 6, and positive 5 pi over 6 are exactly the same location on the unit circle. Okay? They are coterminal angles. So important that you understand that. Okay? These angles that are highlighted are coterminal angles. Coterminal angles share exactly the same ordered pair. So if I have a denominator of 6, I'm talking about the ordered pair, the square root of 3 over 2, 1/2. But I need to know the quadrant in which I'm lying in. So what quadrant is 5 pi over 6 in? Here's 0, here's 6 pi over 6. So that means I want 5 pi over 6, which is right here. So that means they are negative, positive. So if I want the sine of that, let me extend this. So if I want the sine of negative 19 pi over 6, that is the same thing as the sine of 5 pi over 6. And that value is going to be the y coordinate of that ordered pair, which is going to be 1/2. Okay? Now, remember this page in your notes? We're going to apply that here. We are going to apply that here. So it says, use the value of the trigonometric function to evaluate the indicated values. The sine at negative t is 3/8. So I want to know what the sine of t is. Well, we're going to utilize this right here. Okay? That means that the sine of t, so if I utilize this right here, and if I were to take that function and I say, okay, well the sine at negative t is equal to negative sine of t. So if I divide that by negative 1, that means negative sine at negative t is equal to the sine at t. Well, I already know what sine at negative t, it's 3/8. So that means negative 3/8 is going to be the answer at sine of t. So if I know what sine of t is, that it's negative 3/8, Well, then that's going to be the same thing. That's the reciprocal of that. So that's going to make that -8/3 because cosecant and sine are reciprocals of one another. Okay? Next. Number 45. I need to pull up my calculator here. Number 45 says use a calculator to evaluate the expression. Round your answer to 4 decimal places. Now, this says the cosecant of 1.3. 1.3 is in radian. Okay, I'm waiting for that to pull up here. Give me 1 second. Come on. Okay, so you are going to use your calculator, and you are going to use the calculator page. Okay, and you're going to go to the trig function, and you are going to say secant, cosecant, and that value was 1.3, so I'm going to type in here 1.3. Make sure that you're in radian mode. I go over to my battery and I click on it, and it is, and I hit enter. And that's going to go 4 decimal places. 1.0378 is going to be your answer, okay? So you would take this whole entire decimal, taking off the 2 at the end, okay? Now, the other way you could do it is if, let's say, your calculator doesn't have the cosecant key, you can actually go ahead and hit your trig key and do, 1 divided by trig sine of 1.3. And it's going to give you exactly the same thing. So my calculator does give me the cosecant function. Most calculators do not, so you're going to use 1 over sine of 1.3. And again, making sure you are in radian mode, super important. Radian mode is right here, and that's what you want to always be in. Okay? So this is going to be your answer. And I think that is all of your homework for tonight. If you have any questions, please make sure you let me know.